Mr. Simpson back here with our second video for Chapter 14, 14.2 pH and pOH. If you have a swimming pool or a hot tub or a fish tank, you've probably dealt with pH values, and it determines or tells us something about the acidity of the solution. If you've noticed as coming out of the first section and dealing with uh, kW and values that are have the scientific notation with these large negative exponents, those can get a bit cumbersome. So to make it a little easier, if you take the logarithm of those values, of values ranging from 0 to 1.0 times 10 to the negative 14th, obviously in the negative direction less than 1, if you take the logarithm of those values, then you get values that range from 0 to 14, and so that becomes a little easier to manage and tell the difference in size and relationship, and also provides us a scale known as the pH scale. So let's think about what we know at this point. And all of these relationships and equations are going to be interchangeable, and we're going to have to work through all of them. So we already know that Kw equals the concentration of H3O plus times the concentration of OH minus. And we know the Kw value is 1.0 times 10 to the negative 14th. Okay, if I were to take the negative log of the H3O plus concentration, I would then be calculating the pH. If I were to take the negative log of the OH minus concentration, I would be calculating the pOH. And then finally, the relationship between pH and pOH is, if added together, those equal 14. Take a second to make sure that you have these four equations, relationships copied in your notes. You see, I have added a example problem down below here, but one of the things before we get to that I want to really point out is the relationship here between the concentration and what you're solving for. Again, it's pOH and the H3O plus, and the OH minus and the pOH. So with these four equations, expressions, you can navigate your way from one to any of the other three. So if you think about, when I say three, I'm talking about pH, pOH, concentration of H3O plus, and the concentration of OH minus. So with those four expressions there, you can navigate your way from one of those to any and calculate and figure out any of the other three. You just have to make sure that, if you're taking the negative log of the OH, you're not getting the pH, you're getting the pOH. So for example, in this problem, as always, we're thinking about what's the problem asking for, what is the pH, and what is it giving me? Now it is giving me the OH ion concentration. Okay, so this is example I'm talking about. When I take the negative log of 5.0 times 10 to the negative 8, I'm getting the pOH, not the pH. So I can get the pOH and then use pH plus pOH equals 14. So there's a couple different ways you could, paths you could follow here, right? So if I did this first and solved for the pOH, we would get, you see here we get a pOH of 7.3. So now to get the pH, I would say 14 minus 7.3, and I would get a pH of 6.7. We'll talk about the pH scale in a minute to answer the second part of this question, which is it acidic, basic, or neutral? I could have also gone in a different direction, and I could have used that OH minus concentration and calculated first the H3O plus concentration by using our Kw, and then from there, taking the negative log of that value to get our pH. So we would get a H3O plus concentration of 2.0 times 10 to the negative 7th, and when I take the negative log of that value, again, now that's the H3O plus, so now I am getting the pH, and I would get a pH value of the same 6.7. Okay, so you can see we can go in either direction and get there, and I'm going to show you that again in a second here with a little table that we need to be able to complete. But before I get to that, let's talk about this idea of acidic, neutral, or basic. So our pH scale, you'll see here that 7 is neutral. So if you think about, if I took the negative log of 1 times 10 to the negative 7th, which remember, that was the value that we said was the concentration of my H3O plus and the concentration of my OH minus for a neutral solution. So if I took the log of that, the negative log of that value, I would get 7 exactly. So 7 on the pH scale is neutral. Anything below 7 would be considered an acid. Anything above 7 would be considered a base. Later on, we're going to talk about relative acid-base strengths in a future section, but basically, obviously, the further away from 7, the stronger the acid going in that direction, or the stronger the base going in the other direction. So let's wrap this up with the table I was talking about. So you can see here we have our categories that I mentioned before. We have the pH, the H+, again, H+ and H3O+ are kind of the same idea. It's the acidic nature of any solution. So often, I said earlier, often written as just H+, pOH, and OH-. So again, if I gave any one of those, we should be able to navigate our way through those four relationships we talked about before, and to get the other 3 missing values. So for example here with the H+ of 5.4, if I took the negative log of 5.4 times 10 to the negative 4th, I would be calculating the pH, okay, and I would get that value to be 3.3. All right, so now I could use the pOH would equal 14 minus 3.3, or a 10.7. And now going the other way, it would be the inverse log. But remember, there's the negative sign in our formula there. So pH equals negative log of H+, and pOH equals negative log of OH-. So if I wanted to go in the other direction, so I had a pH or pOH and wanted to get the concentration, it would be the inverse log, second function of the log key. But I need to make that 10.7 value negative. So in your calculator, 10.7 negative, and then second function of the log, and you get 2.0 times 10 to the negative 11th. Okay, we have a pH less than 7, so this is acidic. Okay, so we need to be able to, whatever we're given, and again, if we think about those relationships, so they're the first two, and then Kw equals the concentration of H3O plus times the concentration of OH minus, and again, Kw equals 1.0 times 10 to the negative 14th, and then finally pH plus pOH equals 14. So with those relationships, you should be able to, given any one of those values, calculate the other 3. So why don't you go ahead and pause the video and see if you can solve the rest of those for practice. Okay, you can see I have added in those values for B, C, and D here. So go ahead and check your work. This wraps up our second video for chapter 14. So at this point, we should be, this is obviously the big portion of this chapter, this section is these relationships and calculations. So you will see those in your upcoming quiz and practice.